Okay, this is Algebra 2, and this is Log Properties, Day 2. If you have log base b of b, it's going to equal 1. In other words, if your base and the number after it are the same, it's always going to equal 1. So log base 3 of 3 is 1. Log base 2 of 2 is 1. Log base b of 1 is equal to 0. It doesn't matter what your base is. If you have a 1 here, it's going to equal 0. So log base 5 of 1 is 0. Log base 2 of 1 is 0. Those two log rules or properties, they're basically just for shortcuts. If you see them and recognize them, it's great. If you don't, it's okay. You'll still get there. Okay, it's just kind of a shortcut. A reminder of our properties from day 1 is addition becomes multiplication. So log base 2 of 7 plus log base 2 of 5 would become log base 2 of 35. 7 times 5. Remember that subtraction becomes a fraction. So log base 2 of 3 minus log base 2 of 2 would become log base 2 of 3 over 2, or 1.5. Remember that if you have an exponent, it can be moved to the front. So log base 2 of 5 to the third is the same thing as saying 3 times log base 2 of 5. Log base 10 of 10 to the k is always going to equal k. And the reason for that is that your k moves to the beginning. And then we know that log base 10 of 10 is equal to 1. Okay, so log base 10 of 10 to the ninth. You move the 9 to the front, and that gives you this. You realize that log base 10 of 10 is equal to 1. So 9 times 1 is 9. Once again, it's just a shortcut if you happen to see it. Okay, so what your goal is here is to get to where you only have one log on each side. So addition becomes multiplication, and you have log base 4 of 5x equals log base 4 of 60. Your log base 4s are going to cancel, and it's going to leave you 5x equals 60. You're going to divide by 5, and you're going to get x equals 12. You know that it's log base 10, because when they don't write the base, you know it's 10. So you know that your logs are going to cancel, except you should have moved that number to the front or to the top first. So that gives you 27 is equal to x to the third, cubed root it, and 3 is equal to x. You're going to have to move this 2. Then addition becomes multiplication, so log base 9 of 4 times 5 squared equals log base 9 of x. Your logs cancel. 4 times 5 squared. Be careful, you've got the squared just goes with the 5. So 5 squared is 25 times 4 is 100. Okay, be careful and realize that the squared is only with the 5. You can't do 4 times 5, enter, and then square it. Subtraction becomes a fraction. So log base 5 of y over 8 equals log base 5 of 1. Your logs cancel. Y over 8 equals 1. So you take this over here and you multiply by 8. Y equals 8. Log base 9 of 4 plus 2 times log base 9 of something. Hang on and let me get another paper so I can see what these numbers are. Okay, so it's log base 9 of 4 plus 2 times log base 9 of 5 equals log base 9 of w. You got to deal with this 2 first, and so it becomes log base 9 of 4 plus log base 9 of 5 squared equals log base 9 of w. Addition becomes multiplication, so log base 9 of 4 times 5 squared equals log base 9 of w. Your logs canceled, and 4 times 5 squared, 100 equals w. Log base 5 of y minus log base 5 of 8 equals log base 5 of 1. Subtraction becomes a fraction. So log base 5 of y over 8, I'm thinking we've already done these, equals log base 5 of 1. So these are going to cancel. Y over 8 equals 1. Multiply by 8, y equals 8. It won't hurt us to do them more than once, though. Now here's when we have it done. Log base 10 of x plus log base 10 of 3x minus 5 equals log base 10 of 2. You have to start by looking for numbers in front of log, and there's not one. So what we're going to do here is say that addition becomes multiplication. So log base 10 of x times 3x minus 5 equals log base 10 of 2. My logs cancel, and so x times 3x minus 5 equals 2. And so I would go to my calculator and go to y equal. At y1, I would do x, open, 3x minus 5, close. At y2, I would do 2. Either use your table or second calc 5 and find where they're the same. X equals 2. I'm using my table to get one of them. There should be two answers because it should be quadratic. The other one is probably going to be a decimal, and the other one is negative 1/3. I did second calc 5, enter, enter, enter. Okay, last one on your notes. Log base 4 of n plus 1 minus log base 4 of n minus 2 equals 1. Subtraction becomes a fraction. So log base 4 of n plus 1 over n minus 2. The first one has to go on top, is equal to 1. The problem here is that we do not have a log on both sides, so it won't cancel. When that happens, you rewrite it in exponential notation. So 4 to the first equals n plus 1 over n minus 2. Remember, your base stays your base, and the other two swap sides. So once again, you could go to your calculator. So at y equal, at y1, we would put 4 to the first. At y2, we would do open, x plus 1 close, divided by open, x minus 2 close. Second calc 5, let it draw. Enter, enter, enter. I'm getting errors, and so I'm going to go to my table. X equals 3. I don't know if it has another answer or not. I'm going to go zoom 0 and see what happens. Doesn't look real good. Went back to my table. I'm thinking you just have one answer, x equals 3. Alright, so just a little refresher of what you would do. This 3 would come over here and be an exponent. 4 to the third is 64. Addition becomes multiplication, so 8 times x is 8x. Addition becomes multiplication. They did x plus 3 times x minus 3. They did FOIL, and that's where their x squared minus 9 came from. Subtraction becomes a fraction, so it became 8x plus 6 all over 2, but they all divide by 2. So when you cancel, you get your 4x plus 3. Okay, that's log properties day 2. If you have questions, come see me.